This is Honors Algebra 2 Pre-Calculus. We're doing 10.7 in Pre-Calc, which is polar coordinates. So in example 1, we're going to plot each polar point. I gave you 3 points and 3 grids. Before we start, I just updated the Chapter 10 homework so that there are a few PDFs of polar graph paper that look like this. You don't have to print them, you don't have to graph on them, but it's so you can also find them, oh sorry, I forgot it's going to be upside down. You can find them on embeddedmath.com, which is where I got this one, and I'm not sure where I found the other one. You can totally do what I did and draw these by hand, but I'm just going to throw out there that it's no fun, and it's time consuming, and it's a real pain. So if you want, these are not a bad idea. They make life a lot easier. This particular one only goes out to, I believe, a radius of 4, 1, 2, 3, 4. You could add rings, or if you really had a big number, like if you had like a 10, you could actually make like cut each ring in half so that the grid had more concentric rings. It's up to you, but I'm just saying it's really worth having this paper so you don't have to suffer through drawing them by hand like I did. So we're going to plot each polar point. So let's start with this first one. So remember that this tells you what direction to face. So I didn't put the lines on here, but we know pi over 2 is right here, right? It's so because we're starting, it's the same way you measure angles in unit circle, right? You start at this positive x-axis, and going this direction is a positive angle, and going this direction would be a negative angle, right? So a pi over 2 is right here, and then I'm supposed to walk 4 units in that direction. So from the pole, I go 1, 2, 3, 4, and that point is right here, right? So what's worth noting is it's the point 0, 4 in rectangular coordinates. And what we're going to talk about after this video is we're going to talk about actually how you can change polar to rectangular and rectangular to polar. But it's the same spot as if I told you to go to 0, 4, right? I think I just said 4, 0. I might not have. I don't know. I'm tired. So, okay. So that's fine, right? If I do the next one, right, for B, I'm supposed to go to 2 pi over 3. Well, 2 pi over 3 is this angle right here. I didn't label it on the, it's sort of like it's the 120, it's the 60, or the pi over 3 that occurs in quadrant 2. And I'm supposed to go from there negative 2. So that's going to mean go backwards, which really means I'm going towards 5 pi over 3, 2 units. So that's going to be right here, right? So it's worth noting that if I were writing this in polar, it's actually the same in polar as saying go 2 units towards 5 pi over 3, right? It's a different way of telling you the same information, because this says face 2 pi over 3 and then walk backwards. I could have said face 5 pi over 3 and walk forwards. And again, we'll talk about how to convert them in rectangular, because this one's a little bit more difficult than the last one to convert. I'll do this one in red again. Now 3, 0 means face the angle of 0, which is just the positive x-axis, and walk 3 units. So what's crazy about this is my r and my theta, but in rectangular, this one's actually the exact same point, because it's 3 units in the x and 0 units in the y. So this is one of those rare points where it's actually the exact same point in polar that it is in rectangular, which is just weird. It's a weird fluke, but it is exactly the same point. Cool. So after this, we're going to go ahead and talk about how to convert between the two locations, or two coordinate systems.